This chemistry tutorial provides a basic introduction into the atomic size, which is measured in terms of the atomic radius. This is one of the four main periodic table trends you need to know. So let's talk about atomic radius. What is the atomic radius of an atom? Well, let's draw an atom with circular orbit with the innermost shell with principal quantum number n equal to 1, then n equal to 2 and n equal to 3. So the radius of an atom is the distance from the center of the atom, which is the nucleus, to the outermost shell. Now what about those atoms which exist as molecules? Now I'm going to take the example of bromine, which exists as a diatomic molecule. So bromine consists of two bromine atoms, and the distance between the nuclei of the bromine atoms in this molecule is 228 picometer. So the atomic radius of one bromine atom is going to be half of this value. So that is 114 picometer. And that's how the atomic radius of elements are calculated. Now let us understand the trends in the periodic table. We would look at the trends down the group and across the period on the basis of the atomic size. You need to know that as you travel towards the right towards the periodic table, the atomic radius decreases. The size of the atoms gets smaller as you go from left to right, generally speaking. Now, of course, you might have some discontinuities as you go from left to right, but the general trend is that atoms get smaller going from left to right. So this would be a lithium atom. This is going to be beryllium, and then boron, carbon, nitrogen, oxygen, and fluorine. So as you can see, the size of the atoms decreases as you go towards the right. Now I'm going to put some numbers to go with this. So lithium has an atomic radius of 152 picometers. Beryllium is 113, boron is 88, carbon 77, nitrogen 70, oxygen 66, fluorine is 64. I believe neon is slightly bigger than fluorine at 69. So as you can see, there would be some exceptions, but generally speaking, we go from left to right, the atomic radius decreases. The question is why? Why do atoms get smaller? So all of these elements, they exist in the same energy level, that is the second energy level. However, as you go from left to right, the nuclear charge is increasing. Lithium has 3 protons, so the charge on the nucleus is positive 3. Fluorine has 9 protons, so the nuclear charge on fluorine is plus 9. And so what's happening as you go from left to right, the effective nuclear charge is increasing. So that causes the atomic radius to decrease. So because the nuclear charge increases, those extra protons, they have a stronger effect on the outer valence electrons. So they pull those electrons towards the nucleus, making it smaller. So let's see if we can draw a picture. So let's draw lithium and fluorine. So lithium has a nuclear charge of positive 3 and fluorine has a charge of positive 9 in the nucleus. So this is the first shell of lithium and this is the second shell. Similarly, this is the first shell of fluorine and that's the second shell. In the first shell, both of these atoms contain 2 electrons. Lithium contains 1 valence electrons, while fluorine has 7. Now this electron is shielded by 2 electrons. So it feels an effective nuclear charge of plus 1. To calculate this, you take this number 3 and subtract it by the 2 core electrons. Now the nucleus exerts a force of attraction on this electron. However, these electrons, they repel this electron, so they shield it from the nucleus. Similarly, this particular valence electron feels an effective nuclear charge of plus 7 9 minus the 2 core electrons. So as a result, the force that the nucleus exerts on an electron is a lot stronger. That's why it pulls the electrons closer towards the nucleus, thus making the size of the atom smaller. And so, as you go from left to right, the effective nuclear charge increases, there's less shielding, and so the atoms become smaller. Now, what about going down a group? It turns out that the size of the atoms get bigger as you go down and get smaller as you go up. But let's focus on going downwards. So sodium is a lot bigger than lithium, and potassium is even bigger. So this is Na. The atomic radius of sodium is 186 picometers, whereas in potassium it's 227. So clearly, we can see that as you go down, atoms are getting bigger and the atomic radius is increasing. The question again is why? So let's compare lithium and sodium. So once again, lithium has +3 charge in the nucleus and sodium has a charge of +11. So lithium has 2 energy levels, but sodium contains 3 energy levels. So now you can see why sodium is a lot bigger than lithium. It is due to the extra energy level that was added. So as the principal quantum number increases, then the orbital size is also increasing. And as a result, the atomic radius goes up. And that's why sodium is bigger than lithium, because sodium has 3 shells while lithium has 2. So the more energy levels you have, then the bigger the atom. In the first shell, lithium has 2, and in the last shell, it has 1 electron. So if you look at the effective nucleus charge on that electron, it's going to be 3 minus 2, which is +1. While in case of sodium, we have 2 in the first and 8 in the second, and 1 in the last one. So the effective nuclear charge on that valence electron is 11 minus the 10 core electrons, which is also +1. So as you go down in a group, the effective nuclear charge doesn't change. So for all of the alkali metals, in a single column, they have the same effective nuclear charge. So the effective nuclear charge doesn't play a role in the atomic size that we see in a column. It only plays a role as we go from left to right because it changes from left to right. But within the column, an effective nuclear charge is the same. So just to summarize, as you go from left to right, the reason why atoms get smaller is because the effective nuclear charge increases and there is less shielding. But as you go down the group, the size of the atoms, the atomic radius increases because there are more energy levels. The size of the orbitals are getting bigger. So that's it for now. Happy learning!